Dear students, today I am going to discuss about basic decision tree learning algorithm, which is called as ID3. In the last class we have seen what is mean by basic decision tree learning method and how the decision tree is constructed in general and how we can read the values in the decision tree. Positive example how we can read, negative target function how we can represent, etc. So now we are going to see the one of the decision tree learning algorithm called as ID3 algorithm. So the here in the basic decision tree learning algorithm have been developed for learning decision trees or variations on a core algorithm, so that employs top-down approach. Already we have discussed in the previous class. Top-down approach is used, that is starts from root, moves towards the leaf node. Top-down approach is used along with greedy search method. Okay, I think already you have studied the greedy method, like finding the minimal spanning tree, distrust algorithm, all you have studied in Dano, that is greedy method, spanning trees, prim skulls, etc. Okay, that techniques can be used for constructing the decision tree. So this approach is called as ID3 algorithm, and its successor is called as C4.5 algorithm. So what is ID3 algorithm means? ID3 stands for iterative dichotomizer 3. Iterative, I represent iterative, D represent dichotomizer 3. Okay, ID3 is a precursor to the C4.5. C4.5 is the successor of ID3. So algorithm. So the ID3 algorithm was invented by Rose Quinlan in 1975 itself. Okay, use it. So now you can understand the 1975 itself ID3 algorithm is developed means, so that AI and machine learning concept is used from that day onwards. So use it to generate a decision tree from a given data set by employing, already we have seen top down, greedy search method should be used. The resulting tree is used to classify future samples. So once based on the training example, the decision tree is constructed, means using this ID3 algorithm, future examples anything comes, we can classify that whether that is a positive or negative. Okay, so that can happen. So here especially the discrete valued function should be used. Okay. So for example, the ID3 algorithm, this ID3 algorithm takes three parameters as arguments. The first one is examples. What are the training example we are taking? That is a examples. And then target attribute means what is the target function. So here what is the value should be predicted, target attribute. For example, in our previous example, the enjoy sport is the target attribute. Okay, that will be predicted. Either person can enjoy the sport or not enjoy the sport. That is a predicted variable. And attribute. Attribute is a list of other attributes that may be used to predict the targeted attribute. Okay, so it returns a decision tree that correctly classifies a given example. After taking this, it is going to return the decision tree. So first create a root node of the tree. First thing is we have to create the root node of the tree. Then if all examples are positive, the training example contains all are positive training examples, means then returns a single node tree root with label as plus. If all examples are negative, returns a single node tree root with label minus. If attributes is empty, then attribute is empty. There is no attribute itself, means return a single node tree root with label equal to. Okay, so this you should understand. All the examples are positive means only one root node will be there with positive. If all training examples are negative means only one node will be there negative, minus. Okay, otherwise if there is no attribute itself means then there is a single node tree root with a label equal to. Okay, this is like this way we have to construct the decision tree. Okay. So otherwise Otherwise, so there will be a fully positive, fully negative or empty attributes means it's okay. Otherwise, there is some positive training examples, some negative training examples means we should go for this procedure. Okay, so A, the attribute from attributes that best star classifies the example. That means the best attribute we have to find out. Okay, suppose we are having, for previous example we'll take, we are having 6 attributes. Among the 6 attributes, first we have to find out the, that is best attribute. Okay, that will be the root node. How we can find out the best attribute means using information gain. Okay, so we are going to find out the information gain of all the attribute. Which attribute will be having more information gain? That will be the root node. That we have to do it. So the decision attribute for root is A. Now it will be identified. Then for each possible value Vi of A will be having many possible values. Okay, for each value, add a new branch below the root. We have to add a new branch. Suppose for example, that first node, we have taken this here. The previous example we have taken, no? So in that the first node is here that example, for example first node is humidity, will take, mean it takes 2 possible values. So 2 branches we have made, we have to create it. So that is the thing. So add new branch, tree branch below root corresponding to a test Vi equal to Vi. Let examples Vi be the subset of examples that have the value Vi for A. If examples Vi is equal to empty, after that it is empty, means otherwise it will be continued. The same process will be continued for other node. So first root node will identify, then it will be having, the person is having 3 branches, mean the value will be represented. After that, next 6 attributes are there, no? One is taken as a root. Then next among that 5 attributes, next dominating node we have to find out. Same technique will be applied. That information gain. Among that 5 which will be having the more information gain, that will be taken as a next level node. And so on. Okay. So the central choice of ID3 algorithm is selecting which attribute to test at each node in the tree. That is the main thing for each node. Okay. The statistical property called information gain. It is used to find out the best attribute in each step. Okay. So this we'll see this. Okay, in order to find out the information gain, first we should find out the entropy. Okay, entropy, that is what is meant by entropy means. So to define information gain, we have to define first entropy. Entropy measure the impurity of a collection of examples. We'll be having a set of examples. In that examples, the impurity can be defined, that is defined by using this entropy. Okay, that is in order to measure the impurity, the entropy can be used. Okay, for example, given a collection S, there is a collection S. That S contains some 10 examples, like that you assume, containing both positive and negative examples. So always the training examples will contain both positive and negative of some target concept. Some target concept will be there. You assume that enjoy sport game only. There what target concept is, whether person can enjoy sport or not. Enjoy sport is a target concept. The entropy of S relative to this Boolean classification is entropy of S is equal to minus P plus log 2 P plus minus P minus log 2 P minus. So what is P plus means is the proportion of positive examples in S. P minus is proportion of negative examples in S. Suppose for example, previous example we have taken only 4 training examples. In that 3 are positive, 1 is negative. So P plus is 3 by 4 and P minus is 1 by 4. Okay, like that we should take. So for this training example we'll take. So how many positive? There are totally 14 training that instances are there. In that how many positive or negative are there? 1, 2, 3, 4, 5. 5 negative training examples are there and 9 positive training examples are there. Then how it will be represented? Entropy. So this is a collection of 14 examples. 9 are positive, 5 are negative examples, then entropy of S is related to this Boolean classification is entropy of 9 plus indicates 9 positive, comma 5 minus. Like this we have to give entropy of 9 plus, comma 5 minus equal to, what is P plus? P plus is proportion of positive examples. In this proportion is 9 are positive.